A pico is a persistent compute object. Picos were created by Pico Labs at Brigham Young University. You can visit our website at picolabs.io. A pico is both an object and a computer. We'll talk about it being an object first. In other object-oriented systems, an object is created after a class or prototype and is created from it. A pico is created empty and given functionality later. We'll represent a pico by a rounded rectangle. The word pico is not an acronym, but it's fun to think of it as an acrostic. P is for persistent. A pico persists. I is for identifiable. A pico has a globally unique ID. We'll represent this by an arrow pointing to the pico. C is for concurrent. Execution in one pico proceeds at the same time as in other picos. O is for online. A pico is a first-class internet citizen with many URLs. A pico is not addressed on the internet by using its identifier, but rather through one of many channels with which it will have been given. The best practice is to give a pico a channel for each of its applications, which allows it to be revoked easily. We'll represent a channel by a small circle on the edge of the pico, 4 shown here. A channel has a distributed identifier, or DID, which includes an associated pair of public and private keys. The DID can be looked up on the sovereign distributed ledger, which is stored in a blockchain. And when you look it up, you'll find a DID document, which contains the public key and endpoint URLs. A distributed identifier, or DID, is an emerging internet standard. It would have the form DID:SOV for the sovereign blockchain, ABCD, assuming ABCD were the sovereign DID for this pico. The DID is looked up on the blockchain, and we find a DID document which provides a service endpoint. The provided DID is then transformed into an HTTP URL. Before moving on from the pico as an object to the pico as a computer, it is worth mentioning the developer user interface. Pico Labs provides a developer UI for convenience, but picos can be created and deployed independently of that UI or of any particular UI. Besides being an object, a pico is a computer on the internet. Its runtime facility is provided by a pico engine, which interprets rule sets which specify the state and behavior of a pico. The rule sets define how it reacts to events and responds to queries. We'll represent the pico engine by a rectangle in which the pico is embedded. When an HTTP request comes in to the engine identifies by the pico by the channel whose DID is in the request, and evaluates rules or functions to prepare a response. The pico engine is the runtime system. Besides being able to create picos, it can give them channels and rule sets. Pico Labs provides a reference implementation, which we call the Node Pico Engine, or NPE, and you can find this open source project on GitHub. Rule sets specify the stateful behavior of picos. In our reference implementation, this behavior is specified in the KRL language and is compiled into JavaScript modules. You store your KRL source code with a KRL extension somewhere in the cloud. This is processed by the KRL parser and KRL compiler, which are built into the Pico engine. And the output of this is a JavaScript module identified by a rule set ID or RID. Once an engine has registered a rule set and has its rule set identifier and JavaScript module, that RID can be installed into a pre-existing pico. We represent the installation of a rule set in a pico by giving it a silo labeled with the RID, At the base of the silo, you can see the state information that the rule set maintains in the Pico. A Pico can have any number of installed rule sets, each one of which gives it specific computational behavior and state. When a Pico receives an event, one or more of the rules in its rule sets specify how it will react to that event. When it receives a query, that query refers to just one of its rule sets, which will specify how to respond to the query. For an event, several rules may be selected. Each will perform calculations, act upon the outside world, such as sending events to other Picos or preparing a reply, and then it will affect internal changes, such as raising further events to itself or mutating the internal state of the Pico. A query, on the other hand, is like a request-response. The Pico responds to a query by performing a calculation and returning a result. It will neither send events nor change the state of the Pico. Picos are persistent compute objects. Please visit our website at picolabs.io.